Now, I've mentioned a lot about using code that other developers have written, and the most common way to do this is through using packages of code. In this lesson, I'll show you how to integrate an existing package of code into our project so that we can practice creating objects and working with attributes and methods. Now, we've seen modules of code where each file that we create in our project is essentially a module in itself. But a package differs from a module in the sense that it's actually a whole bunch of code that other people have written. Lots and lots of files all packaged together to achieve some sort of goal or purpose. Now, let's say that we wanted to create a table of Pokemon and their type. So we wanted some way of documenting that Pikachu is an electric type and maybe Squirtle is a water type. Now, if we wanted to do that in ASCII so that we could print it in the console, well, then we would have to go about formatting it, and it'll be quite painful. So we might have to print some sort of pipe, and then maybe we would have the name of the field, so Pokemon name, and then maybe another pipe, and then we would have the name of the next column, which is their type, and then finally we would close that off. And then we would have to print some sort of horizontal line, maybe like this, and so on and so forth, just to create this table. And it's quite difficult if you're not used to manipulating ASCII and visualizing it. I certainly am not up to this task. So what could we do instead? Well, we could search for a package that other developers have created to achieve this goal. And the place that we would do that is somewhere called PyPy, which is the Python Package Index. And this is a bunch of software for the Python programming language that is developed and shared by the Python community. So we can see their source code, but more importantly, we can see how to implement the code and how to put it into our project. In here, I'm going to search for something called Pretty Table. And this is a very simple library that is going to help us to display tables in a ASCII format. We can click on the project links to find out more about it. And this will take us to the Google Code Archive where the documentation is hosted. If you go to wikis and go to tutorial, you'll see some documentation on how to use it. Now, this particular package is not as extensive as the Turtle graphics package. So there's actually not a lot of things you can do with it, but it's got more than we need for our use case. The first thing we have to do is to install this package into our project. Now, unlike the Turtle package, which is already preloaded with every copy of Python, in order to use the packages that you find in the Python package index, you actually have to install it. So here's how we do it in PyCharm. First, go to the Preferences. So in Windows, I think it's under File and then Preferences. On Mac, it's under PyCharm and then Preferences. And then here, you'll see a whole bunch of things you can change, including the editor or appearance, which we've already messed around with. But I want you to click on your project. So my project is called Day 16 Start, and then we're going to go into the project interpreter. And here we can click on the plus button to install any package that you find in the Python package index. Make a note of what it's called. So ours is called Pretty Table, and then we're going to search for it inside the available packages. And once we've found it, we're going to select it and then click Install. If you're working with Replit, you can also install packages just by going to the Packages tab and then again searching for Pretty Table. Once you've clicked on the package you want, click on the plus button to add it to your project. Now, Replit is a little bit weird because it says installing, but it never actually confirms the success. But once you click Run, everything will go through and it will work perfectly, as long as you see it in your list of packages here. Now, if you want to remove the package, you can simply click on the minus button, but now we're going to work with it. So now it's installed successfully. we can go ahead and close this down and click OK. And we can now access this package called Pretty Table in our code. Again, I'm going to import it. So I can say import Pretty Table, and now I can use everything that's inside this package. Now, if you want to see the source code, you can actually right click on it and select Go to Implementation, and this will take you to the Python file where this entire Pretty Table is implemented. So all the code that they've written. It's a little bit daunting and it's got a lot of code in it, but we don't have to worry about how the code is created and how it works. All we need to do is look at the documentation for this package and see how we can implement it into our project. Now in the next lesson, we're going to get some practice constructing a Pretty Table object and using the documentation to explore this object's attributes and methods. For all of that and more, I'll see you there. In the last lesson, we added an external library to our project. Now it's time to construct a Pretty Table object and practice using its methods and attributes. Our starting point, as always, is the documentation. Here you can see how to construct an actual Pretty Table object. So let's use what we've learned previously about constructing objects to go ahead and create this object from the class. Now, firstly, we're going to do the same thing as we did previously with Turtle. We're going to tap into the package Pretty Table, and then we're going to import the Pretty Table class, noted by the C here. Now that we have access to this class inside our code, I want you to go ahead and create an object from this Pretty Table class, and the object should be named Table. So pause the video and give that a go. All right, so we said our object is going to be called Table, and then we're going to construct it from this class called Pretty Table. So we're going to put it in with its casing. So this is the Pascal case that we spoke about earlier on. And then in order to actually give it the go ahead and construct, we have to add the parentheses at the end. So now you've created a new object called Table from this Pretty Table. And we can actually go ahead and print this table. And even at this stage, it's already going to start printing out a bare bones version of a table. But of course, this table has no data. So it's actually kind of hard to visualize what all of these ASCII characters are doing in an empty table. But no matter, the next thing we can see in our documentation is how to go about adding columns. So it's got this method. Remember, methods are functions that are associated with an object. And this method will add columns to whatever table we specify. Now, the method takes two inputs. One is the name of the field. So our field names are Pokemon name and type. And then we've got a list of strings, which is going to be the data that's going to go into that column. Essentially, every time we call that method add column, it's going to allow us to give a field name as a string and then a list of data in order that they're going to go into the table. So we're going to add our table one column at a time. Using that documentation, see if you can add both of these columns to our table object. And then once you've done that, we're going to print the table object again, and we should be able to see an ASCII table. This is what you're aiming for when you run your code. It should print out your table and nicely format it in this ASCII style. Pause the video and complete the challenge. All right, so we've got our table object, and remember that methods are functions that are associated with the object. So we say table object dot, and then we get to call that method add column. And notice how it takes two inputs, the field name and the data that's going to go into the column. So the field name is going to be a string, and this is going to be the name at the top of our column. So in our case, it was called Pokemon name. And then after a comma, we get to put in a list of all the data that's going to go into our column. So just as a quick reminder, our first column contains Pikachu, Squirtle, and Charmander. Now we should have added a column to our table. And you can safely ignore all of these typos because, of course, Pokemon names are not real words. But if you wanted to check against the Pokédex, you can actually go to this link in the course resources and you can see how each of these Pokemon are spelt. Now, the next thing we want to add is the associated type with each of these Pokemon. So for example, Charmander is a fire type Pokemon, Squirtle is a water type Pokemon, but essentially we're going to add the data that's in this second column. So the field name is called type, and then we've got 3 pieces of data that's going to need to go into the list in the same order as the previous Pokemon. That way they'll actually match them up properly. So if you haven't already, go ahead and add the second column. So again, I'm going to call the same method on my table, and this time I'm going to add the field type, and the data is going to go in the order of the data that I had from the previous column. So the first one is the type of Pikachu, which is electric, and the second one is the type for Squirtle, which is water, and finally we've got fire for Charmander. So now this will be matched to this will be matched to this, and so on and so forth. If we go ahead and print our table now, so if we run our code and take a look in here, you can see how we've now got a nicely formatted table by creating an object from this pre-made pretty table class, and we've now called this method add column to add 2 columns, and when we print our table, it's now nicely formatted in ASCII. Now remember that we can also change the object's attributes. For example, if we wanted to change the appearance of our table, that's probably controlled by an attribute. If you scroll down, you can see that we can change the table style by tapping into each of these attributes. For example, if I wanted to change the alignment of my data in the table, I can change this align attribute to L for left align, C for center align, or R for right aligned. Do you remember how to tap into an object's attribute? If you do, go ahead and see if you can change our table from center aligned by default to left aligned. Pause the video and try to complete that challenge. So again, we're going to tap into our table object and we're going to use the dot notation, but this time, instead of accessing a method associated with the object, which is of course denoted by the M, we're going to access an attribute, or in this case, they've titled F, which is a field. And the one that we want is this align. So let's go ahead and type align, and now we have access to this attribute. Let's see what happens if I go ahead and print this align attribute. You can see that for both of my columns, Pokemon name and type, the align attribute is set to C, which is centered. What I want to do is change the whole table to be left aligned. Just as we would with any other variable, we can of course print it, but we can also change it. And we would change a variable by just using the equal sign, right? So let's change the alignment to left aligned. And now let's run the code again. And you can see now both of my columns are now aligning with the left-hand margin. So we've seen how we can use attributes like the ones here to change the styling of our table. We've seen how we can use methods like add column or add row to work with this table object and get it to perform some sort of functionality like adding pieces of data to it. And we've seen how we can create new objects by simply constructing it from the Blueprint class. Feel free to mess around with Pretty Table as much as you like, change other things about it or add different pieces of data. But once you're happy with creating the object, changing the attributes, and calling the methods, then head over to the next lesson where I've got a quiz for you. Now, as we start using objects and their attributes and methods more and more, we're going to start to see why it is that they are so useful and so loved by programmers. Now, I think one of the non-programmers that explained OOP the best is actually the late Steve Jobs. And he has this brilliant example that makes it really clear why objects are so great. In his story, he talks about this concept where, let's say you were traveling to Japan, and after a long flight, you finally land and you go outside and there's beautiful cherry blossoms, Mount Fuji's looking wonderful. But unfortunately, on the flight, you had soiled your t-shirt. You were overly eager with the tomato juice and you spilled everything on yourself. So what do? Well, you're in this unfamiliar city and you have no idea even where the hell you are, let alone where to find the nearest dry cleaners or laundrette. And plus, on top of that, you don't have the local currency, they take yen, but you only have pounds, and you don't even speak Japanese. So what do? It's going to be a real struggle trying to solve this problem. Well, you're staying at a hotel, right? And the hotel staff probably speak English. So you go to the receptionist and you tell the hotel that, hey, my t-shirt is soiled. And they say, hey, no problems. We'll take that from you and we'll go and handle all of that messy stuff. We know how to find the dry cleaners, we can pay them in the local currency, and we speak the local language. And what you get back is just a nice, clean t-shirt. So this is similar to the process of working with objects. Essentially, if you have this hotel object, which has a blueprint for how to handle dry cleaning some sort of clothing, then all you have to do is just get the object hotel and then call its associated method dry clean, and then it will do all of the messy stuff for you. And you don't have to worry about the implementation of this function at all. So now you can work with multiple objects, getting them to do different things and trust that they know how to manage their data and how to perform the necessary functionality. Coming back to a problem that we've already solved, creating that coffee machine with all of the program requirements, well, it's time to put our object-oriented programming knowledge to the test, because we're going to be making a OOP version of our coffee machine. Now, the program still has the same requirements as before. You have to print reports for all the resources, you have to check the resources are sufficient, process coins, check transaction is successful, and finally make coffee. But in this case, you're going to be working with objects. In the course resources, you'll find a link to the starting project for the OOP coffee machine. So if you head over to this link, you can see that there's a whole bunch of code that we've already written for you. Now, the idea here is you're not going to touch any of these other files, the money machine, the menu, or the coffee maker. All of that code has already been written for you, and it's almost like you're working with an external library. You're just going to trust that they do what they say they do. And you'll find a link to this coffee machine documentation that I've created, which describes in detail what each of these classes or blueprints allow you to do. So once you construct an object from the menu item class, then you have access to the name attribute, the cost attribute, ingredient attribute, and there's also descriptions of what it should do and what an example might be. You have access to all of these classes and you can build objects from each of these classes to solve this project. In order to work with PyCharm, all you need to do is to download the zip file with all the starting code from our course resource website. Alternatively, if you're already logged in on Replit, simply fork the project and then click on these three dots to download the zip file here. Now, once you've found that in your downloads folder, all you have to do is uncompress or unzip it. And then you can go into PyCharm and open it here. So click on the open button and then navigate to where you had that folder downloaded. Remember, it needs to be unzipped. If you're on Windows, right-click the zip file and choose Extract All. Then click Extract. You should see an unzipped folder pop up next to your zip file. If you're on Mac, then all you need to do is just double-click on the .zip file. Now if we click Open on that folder, then it will open up this project, and when you open up the project folder, you'll see all of the same files. Now you're only going to be working from the main.py. In fact, I don't even want you to care that much about the code that's in the other files. It has class definitions and a whole bunch of other things that we're going to learn about in the next lesson. But for now, I want you to treat it as if it is an external library, which you're just going to use. At the very beginning of the main.py file, I've already imported all 4 classes that you're going to be using: menu, menu item, coffee maker, and money machine. Now, all of these classes are documented in the Coffee Machine documentation website. All you have to do is head over to this website and read through what each of the classes do. Some of them have attributes and methods, others just have methods. So each of these classes have already pre-written code that do a lot of the heavy lifting and all of the code that we had to write when we wrote the Coffee Machine code from scratch. But this time, you're only going to be using these 4 classes and the objects created from them in order to achieve exactly the same goals as before. So while the goals are fresh in your mind from the previous day, you should review the code from the previous day and then have a read of the documentation and see how you would implement exactly the same project, but this time using only the objects created from these classes. You'll need to spend some time on this because you'll need to think through how to create objects from these blueprint classes and then how to use the objects, how to call the methods, and the logic that's required to put everything together. Pause the video now, have a think about this problem, and try to make the coffee machine do exactly the same and have all the same functionality as the coffee machine that you created in yesterday's project. If you got stuck or if you had any problems completing this project, the first protocol is to review the lessons you learned today. It might just be that you need to see some of the theory a few more times and listen to it a few more times and practice it a few more times before you're ready to tackle this final challenge. But if you have completed it and you just want to see the solution, then I'm going to go through it with you right now. Again, we're going to complete all of the program requirements step by step. So the first thing is to print a report for all of the current resources in the coffee machine. Back in PyCharm, I'm actually going to collapse this entire project folder because I'm not going to be writing any code other than inside main.py. Now you can see up here, we've got access to 4 classes. And if we take a look inside the documentation, you can see that both the Coffee Maker class and the Money Machine class have a method called report. And this is going to print a report of all the resources like water, milk, coffee, and this is going to print a report of the current profit. So our final report is going to be both a report from the Money Machine as well as the Coffee Maker. Let's go ahead and start off by creating some objects from these classes. For example, the Money Machine is going to be just called Money Machine, or you could call it My Money Machine. You can actually name your objects anything you like. But I'm just going to use the default Python snake case to create a new variable Money Machine, which is going to hold my object. And my object is going to be created, of course, from the Money Machine class. And the construction happens when I add the parentheses. So now I have an object created and stored inside this variable Money Machine. Now, if I want this Money Machine to create a report, then all I have to do is tap into the object and then write a dot and then call the method that I need, which is report. So now if I go ahead and run my code, you can see it prints out the current amount of money in the machine. Now let's do the same thing for our coffee maker. Again, I'm going to call it Coffee Maker, and you see this frequently. The object naming tends to be the lowercase and snake case, so separated by underscores, version of the name of the class. So the name of the class is Coffee Maker, and usually you'll see people name the object exactly the same, but in lowercase. And now that I have my coffee maker, then I can go ahead and call the report method on that object as well. And now if I run my code once more, you can see that I've got everything now being reported and printed out. So in this case, we don't actually have to care how report is implementing all of this functionality. All we have to do is read the documentation, find the method that does the thing that we want, and then trust that it will carry out the functionality as described. Now that we've completed step 1, the next one is to check that resources are sufficient. My first port of call is going to be going over to the documentation, and you can see that the coffee maker class actually has a method called isResourceSufficient, and all we have to do is pass in the drink, which is a menu item, and then it's going to check and give us true if that drink order can be made and false if the ingredients are insufficient. So how do we get hold of this drink menu item to pass over to this method? Well, if we take a look at the menu class, you can see it has a method called getItems. And this is where you really see reading the documentation properly, actually absorbing everything that's in here becomes really, really helpful. This menu class has two methods that are really useful. One, it's able to get a hold of the names of all the items that are available on the menu, and it returns it as a string separated by forward slashes. It's also able to find a drink based on the order name. So if we passed in one of these names to this function find drink, then it's going to return a menu item object if it actually exists. Otherwise, it's going to return none. We're going to need both of these in order to ask the user what they want. Let's go ahead and set up our while loop. As we had previously, I'm going to create a new variable called isOn, and it's going to start off being true. And then while coffee machine is on, well, then we're going to get hold of all the options that we can offer the user. And we get that by calling that method getItems. But of course, because this is a method, it's associated with an object. So we have to create an object from this menu blueprint. So let's do that next to all the other objects being created. So let's create a menu object, and it's going to be created from the menu class, and then we add the parentheses, and now we have access to that object by the name menu. The options are going to be equal to the menu object, and then we're going to call the getItems method. And then when this method returns, it's going to save the string of all the options into this variable called options. Now we can get the user's choice by asking them for what would you like? And then inside a set of parentheses, we'll offer them all the options. And then, of course, I need to turn this into an F string, and the code highlighting immediately tells me that this is actually now working. So once I've got the user's choice, then I can incorporate the reporting behavior into this choice. Remember, previously we said if the choice was equal to off, then that means the isOn is going to be equal to false. And elif, the choice is equal to report. Well, in this case, we're going to get the coffee maker and the money machine to make their reports into the console. Finally, we're ready to tackle the next problem, which is how do we check that we have enough resources? And this is going to require us to find the drink, giving the order name that the user chose from the choice, and then get hold of the menu item, which comes as the output from this method call. So else, we're going to save our drink as a variable called drink, and then we're going to tap into the menu dot find drink. And find drink, you'll notice, takes a order name as the input. So this is a string, and this is going to be equal to whatever the user chose inside this choice. So let's put the choice in here as the input, And now, once we've got hold of this drink, let's go ahead and print it. Remember, we're expecting a menu item object at this stage. So let's click run and let's make sure that we can hit report to get the report. We can say off to switch off the machine and exit the code. And we can also get hold of a latte by passing in latte as the drink that we want. And we now get printed a menu item object at this particular location in the computer's memory. Perfect. Everything is working as expected. Now, instead of printing the drink, I'm going to tackle this step 2, which is to check that the resources are sufficient. Again, that's going to require us to look through our documentation, and you'll see that the Coffee Maker class has that method, is resource sufficient, and it expects a menu item object as the input. And then it's going to return true when it can be made and false if it can't. So let's get hold of our Coffee Maker object and then get it to check if the resources are sufficient to make the current drink that we're interested in. And let's go ahead and print the results here and run our code. Let's say that we wanted to make a latte. That's going to be resource sufficient, so true. Espresso, also true, and a cappuccino is also true. So we can make all 3 drinks basically. Now, instead of printing this, what we want to do is we want to check this is true and then proceed to the next step if there are enough resources. Now, the next step is to take payment from the user and to process the coins and check the transaction is successful. Notice how in our coffee machine documentation for the money machine, we don't actually have a way of processing the coins. But what it does have is it allows us to make payment, passing in the cost of the drink, and then it will return true when the payment is accepted or false if insufficient. So let's see what happens if we actually try to make payment. Let's tap into our money machine object and then call the make payment method, and we have to pass in the cost of the drink that the user ordered. So we've got the drink object here, which remember is a menu item. And each of the menu items have 3 attributes that we care about: the name of the drink, the cost of the drink, and the ingredient list. So this is what we're interested at the moment. So we can pass in the drink.cost, which is the attribute that's associated with the drink object, and that cost is going to be processed by this make payment method from the money machine. And then finally, it's going to tell us whether if this was successful or not. So let's see what happens when we run this code as it is. Let's say I wanted a latte. Notice how it's asking me to insert coins, how many quarters, how many dimes, how many nickels, and how many pennies. As the coffee machine, I don't actually need to care about how the money and the coins are processed. All I had to do is call make payment, and it deals with all of this automatically. Finally, it gives me the change and it returns true, telling me that this make payment was indeed successful. If you actually look inside the money machine code, then you can see that it has a method called process coins, but it's called when make payment is triggered. This class is going to process the coins, and then it's going to decide whether if it was successful or not. And if it was successful, it's going to add the cost to the profit. And if not, it's going to tell you that that was not enough money and your money is refunded. Coming back over here, if this is successful, then that means the user has managed to pay. And we fulfilled step 3 and 4 just using one method. The final thing we have to do is to actually make the coffee. And that, of course, happens right at the end here. And all we have to do to make the coffee is get hold of the coffee maker object and then call the make coffee method. And we can pass in the order, which is our drink. Because remember that the make coffee method expects a menu item as the input parameter. We can actually simplify this code even more by saying, well, if the coffee maker is resource sufficient and the money machine was able to take payment, well, then we can get the coffee maker to make coffee. So now let's go ahead and run our code. And let's report to begin with, see how much resources we have to begin with. And then let's order a coffee, insert lots of money, and we've got our coffee back. So now let's go ahead and order a different coffee, latte, and let's go ahead and insert lots of money, and you can see here's my latte. But now if I hit report, you can see that the objects, the coffee maker has been managing our resources, and the money machine has been managing our profit. Now, if I decided to order another latte, then it should actually tell me, sorry, there's not enough water and there's not enough milk. So it can't make me that drink. And we've managed to achieve all of this functionality by writing very few lines of code. And the code itself is actually very, very easy to understand. So if you find this line difficult, then you can actually just simplify it to make these onto separate lines and save them into individual variables. And then you can check, is enough ingredients and is payment successful? And if both of these are true, then go ahead and make coffee. You can see that this code is very easy to understand, even if you came to this completely fresh. You've never seen how each of the methods are implemented. You don't know how the coffee maker works. You don't know how the money machine works. You can see quite easily what it's trying to do. And so if you only had to write this kind of code, then it would make it so much easier to create even more complex functionality in your coffee machine, right? So have a play around with these classes, the coffee maker, the money machine, the menu item, etc., and see what else it is that you can do with this code while not touching any of the blueprints for each of these classes. Now, in the next lesson, I'm going to be showing you how to create your own classes so that you can actually start structuring your code using full object-oriented programming. And we're going to learn about these things like the initialization and how classes are declared and why there's all this self all over the place. That's all yet to come on tomorrow's lessons.